The topic of the video is what are stationary states and explain their properties. For an n-particle system, the state function can be a function of the position vector of all particles as r1, r2, r3, etc. until rn and the time t. And for such system, the Schrodinger equation can be written as equation number 1. Here the Hamiltonian operator H is taken as the kinetic energies of all particles and the potential energy of the system V. Since the momentum operator of a particle is minus IH cut into del in terms of the spatial coordinates of that particle, we see that all the kinetic energies are actually kind of partial differentials with respect to the spatial coordinates, and this v is actually a function of both spatial terms and time term. And in case if this v is independent of time, then we say that operator h is also independent of time. And for such system, if we actually select our psi as a product of our exponential term which depends on time, and then phi which depends on only spatial position coordinates of the particles. If you substitute this function psi into equation number 1, we end up with this equation number 2, which is called the time independent Schrodinger equation. And such states size are called stationary because the position probability density of the particles, which is psi star psi, it will become independent of time. Of course, it is actually modulus square modulus phi square. And in fact, Mr. Niels Bohr has referred these states as stationary states while explaining the spectrum of hydrogen atom. And to know the energy of the system in some when the system is in some orbits, and to find out the orbitals shape and etc., we have to solve the equation number 2. That's it in this video, and thanks for watching.